The principles of machining have one material cutting another material. In this case, we see steel cutting steel. How can this be that one piece of steel can cut into another piece of steel? This is a factor of heat treatment, the heat treatment of the materials. That's what today's video is about. Hello, thank you for joining me for today's video. Today's topic is heat treatment of metals. So I have some examples here of some metals that I've located around in the shop today, and I'd like to talk about the heat treatment and the metal's condition. All right. What makes heat treating important is the condition of steel or some various other metals can be changed by a process called heat treatment. All right, so our basis of machining is that we can cut one material with another. The condition of the material is critical. All right, so I have examples here of steel. I'm going to focus on steel today that are in various different conditions of heat treatment. So the process of heat treating steel is similar to baking a cake. All right, the material is in the steel. All the critical components are there. A higher carbon content lends itself to heat treatment, whereas low carbon steels don't necessarily respond to heat treatment. So as long as the material is of a higher carbon content, the breakdown of the material is going to determine the recipe, and the steel can be heat treated by baking it in an oven at a temperature could be approaching 1800 to 2000 degrees. All right? And what happens during the heat treating process is it's actually a molecular realignment of the steel. So we're not changing the size of the steel, we're not changing the density per se, but we're changing the way the molecules are aligned in the steel. And that's going to change the condition of the steel and how it reacts to the atmosphere. So when a steel that's a tool steel, a high carbon content steel, is in a soft state, we can machine it. We can saw it, we can drill it, we can cut it with high-speed steel milling cutters or carbide milling cutters. But once we apply heat to that and we bring it up to its baking temperature, the molecules realign and that steel becomes very, very hard. All right, so how hard? Well, the hardness is measured on a scale that we call the Rockwell scale. All right, and a hard piece of steel on a Rockwell scale could be 60 to 62 Rockwell, even 64 Rockwell. That's very hard. That can't be cut with an ordinary cutting tool. It can't be sawed or drilled. All right, it can be cut with carbide tools, and it's a good candidate for grinding operations. All right, the lower numbers on a Rockwell scale, a piece of material that has not been heat treated may be in the 10 to 15 scale on a Rockwell C. All right, the softer materials are measured on a Rockwell B scale. All right, so that's a little bit different circumstance. So we're gonna stick to the harder the steels and the Rockwell C scale. So we're looking at going from a machinable material to a material that we would have to either grind or EDM cut, or some cases we could cut with carbide tools. All right, by heating it and heat treating it. All right, so I've got some materials here that are in various different states. All right, I don't have any fancy equipment here to check them with. We're going to check them with what we have available in the shop. All right, so my first test is going to be with an ordinary file. All right, because I know I can cut an ordinary piece of steel with an ordinary file. All right, it's going to take a chip. I can see where it's cutting. All right, so if I've got a file that I'm used to, I know how it cuts, and I pick up a piece of material that I suspect has been heat treated and is hardened, my file is going to glance right over it. All right, it's not going to take any chip, it's not going to leave any mark on it, it's going to glance right over that. Now I know that part is hard. I don't really know how hard, but I know it's harder than in its machinable state. All right, so a file is a good indication. If I can pick up a piece of steel in the shop, I want to check it and make sure, is it still machinable or has it been heat treated? All right, visually, there is some indication. When a material heat treats, it turns kind of a darker gray. All right, the finish on it is going to appear slightly different. So I can go by a visual check. I can look at it and say, well, it looks like it's been heat treated. All right, but that's not necessarily the best way to do it. But if I check it with a file and I see, all right, it doesn't cut, it looks, it's got that grayish appearance to it, it looks like it's been heat treated, I suspect that it is. So I've indicated here, I've got 3 pieces that have been heat treated, 2 pieces that are still soft. So I've narrowed it down that much simply by visualizing it and checking it with an ordinary file. All right, so I'd like to go a little bit further, and I want to know just how hard these parts are. All right, so I may be working to a specification. All right, in many cases, your blueprint is going to call out a material condition. So it may call out that we need a Rockwell between 60 and 65, 55 and 60, some kind of a range. All right, there's going to be a range given because, like everything else, heat treat has a tolerance. All right, the range is given because even within one part, you could have slight differences due to the thickness of the part, the cross section of the part, where it's going to react different to temperatures. All right, so I want to check one of these pieces and I want to see, I want to get a better idea of where it is on the Rockwell scale. All right, so the material condition on the print is also going to give us an indication of how we can plan our machining. Because once this part is in a heat-treated state, it's no longer machinable by ordinary means, all right? But the finished sizes of it may dictate that it needs to go through a grinding operation or some other post-heat treat finishing, all right? So that's important for the machinist to know what is the finish of the part and what is the condition of the part, all right? Because we may need to leave material on it in machining so that it can be heat treated and then finished in grinding or finished in EDM or another category. All right, so getting past that, I'd like to check this part with a set of hardness testing files. All right, so I have a set of hardness testing files that have a range of, 40 Rockwell C to 65 Rockwell C. All right, so these are color-coded files, and we're going to use these to check one of these parts and see exactly where we fall into that range. All right, so you can cut. All right, here's our set of Rockwell hardness testing files. All right, you can see they're color-coded in a range from 40 to 65 on the C scale. So I'm going to start with the lowest number of 40 and check and see if it cuts into the surface of this part. Now, see, that glides right off of there, so there's no cutting action at all. All right, so we're much harder than a 40. So I'm going to jump up to a 55. All right, I've got a 55. I'm going to take a cut with a 55, and it's just about scratching the surface, but it's really not digging in there. So I think the 55 is not the answer either. So I'm going to move up to 60. All right, again, I'm going to try same area. Now that one I can feel it taking a little bit of a cut. If I apply a little pressure to it, I can feel that it is digging in a little bit. So I would say we're at least at 60. The 65 will definitely cut it. So we're somewhere between 60 and 65. So you can see that's where the range is important in a Rockwell test, certainly for this, this sort of a test. All right, but at least we've narrowed this down. Now we know it is heat treated. We know that it's somewhere between 60 and 65 Rockwell. So it's something that we could not machine. We would have to grind this part or EDM it, okay, for any further machining operations. Okay, this machine here is a surface grinding machine. So this is a good method to machine a heat-treated part. So we've got a grinding wheel that's on a spindle, and we've got a magnetic chuck to hold our work holding devices. In this case, we've got our heat-treated part is in the vise. All right, so the grinding machine can work back and forth, and we can move it in and out, all right, and up and down. So this is going to give us a means to precision finish this heat-treated part. All right, so that's a good method of machining a part that's got that higher Rockwell hardness. Okay, so the last thing I'd like to go over with you regarding heat treatment and checking the condition of metals in our shop is this device here, which is a handheld Acme hardness tester. All right, so a device like this is another means to measure the Rockwell condition of a part. All right, now there are bigger versions of Rockwell testers. They all work kind of the same way. This one is a handheld version, but basically you're putting a small point against your workpiece and you're applying a load to it. All right, we're applying a controlled load, and then the distance that point can penetrate into the workpiece gives us our Rockwell reading. All right, so we can convert that by the force used and the depth that it travels to measure what the density and hardness of the part is. All right, so this is a handheld version. You can set this up with a part in here and apply the load to it and get a Rockwell reading that way. All right, so a few different ways that we can measure the Rockwell hardness on the C scale of a part in the shop, and a few different ways that we can identify whether a piece of material has been heat treated or is a good candidate for heat treat. So thank you for watching today's video. I hope that you learned something about the heat treatment of metals.